Hello, Numi Ninjas. I'm currently learning a new mathematical language called Numatican, which is still maths. It's just different words occasionally and different nomenclature. I'm going to refer to classical mathematical language as SEML, and Numatican by either Numatican or Numi. So CML or SEML is traditional maths, and then Numatican is this new language. And I thought I would just share with you an example using logarithms. Now, I live in Scotland, so I'm aiming all of this at Scottish schools. So that's Nat 5s, Highers, and Advanced Highers. And all of the problems I do will be from past papers, and they're referenced with a 6-digit number, which will be 2 digits for the year. The next digit will be the level. So 1 is Nat 5, 2 is Higher, 3 is Advanced Higher. The next digit is the paper, so that's paper 1. And then the last 2 digits will be the question, so question 14. Now, before we can answer this question, I just need to explain some translations. So to translate from SEML into Numatican. So in SEML, we might have, if we have a relationship A equals B to the power of C, then we can say that B equals the cth root of A, and also log B, base B, of A equals C. So in Numatican, we think of these relationships as a sort of three things, right? We've got A, B, and C, which we would write in our heads. So a lot of Numatican is about cognitive processing, and we think of these with this relationship: A, B, and C. So the first one is written exactly the same. A equals B power C. Okay, the second one is B equals A root C. And for a root, we write it as a subscript. And then finally, here, the logarithm is written log B of A equals C. And if we look at this, we can see, for the moment, if we take out equals C, we can see that it's B to the power what equals A, or A root what equals B. So it's what goes in here from our organization of the 3 letters in our relationship. So we can say that equals C. So in fact, a logarithm is just a number. It's the number that connects 2 numbers by either being the power of one or the root of the other. And then all of our logarithmic rules that you'll hopefully know stand. So for example, in SEML, we would have log base B of A to the power C equals C times log base B of A. And again, if we translate that to Numatican, it becomes log B of A power C equals C times log B of A. And in fact, we can get quite complex. We could have, to take it to the nth degree, log base B power C root D of A power E root F equals E per F times D per C times log B of A. Okay, per. So this the straight line in Numatican we call per. So for example, in Semel we would write a half as 1 divided by 2, which we can also write in Numatican, but for shorthand in Numatican we write per 2. And this bar basically means the reciprocal. It's 1 divided by. That's what that means. Okay, let's get back to our original and also as we know, so like log 2 of 3 plus log 2 of 4 is equal to log 2 of 3 times 4, which equals log 2 of 12. And with negatives, we would have log 2 of 4 minus log 2 of 8, for example, equals log 2 of 4 over 8, or log 2 of 4 times per 8, which equals log 2 of 1 over 2, or log 2 of per 2. Okay, so coming back to our example, let's first of all translate this into Numatican. So that becomes log 10 of 4 plus 2 times log 10 of 5. So we could probably do all this in our head once we get a little bit more proficient, but first of all, let's do it piece by piece. So that's log 10 of 4 plus log 10 of 5 power 2, which is 25. Then we've got an add between the logs, so we can write that as log 10 of 4 times 25, which equals log 10 100. So we ask ourselves, 10 to the power of what is 100? Or we could say 100 root what is 10. And clearly 10 power 2 is 100. So the answer is 2. Now that was part A of a 2-part question. So here's part B. solve log 2, etc. So first of all, let's translate that into Numatican, and we get log 2 of 7x minus 2 minus log 2 of 3 equals 5. Now, we've got two terms which are log base 2, and it strikes me the simplest way to deal with this would be to multiply this by 1 on the right hand side, but 1 kind of expanded into log 2 of 2. So again, thinking about, what's the number here that 2 to the power of this number makes this number, and it's 1. Okay, so log 2 of 2 is 1, or log x of x is 1. Okay, now here we can shift this up here, can't we? So that we'd get then, but we can do some work on this side as well, because we've got a negative in the middle here. So what we can say is log 2 of 7x minus 2 times, that's a divide, so that's going to be per 3, equals log 2 of 2 power 5. Now, both sides are log base 2. So we can just remove the log base 2's, and we end up with 7x minus 2, let's get rid of that, equals, let's take this per 3 across, it becomes a 3. So we get 2 to the 5, which is 2, 4, 8, 16, 32. So it's 32 times 3 becomes 96. And then it's basic algebra. 7x equals 98. So x is equal to 98 divided by 7, which is 14, I think. And there's our answer.